Alexa, turn on ring light.
Okay.
Hi, I'm Andri, CEO and co-founder of DycodeX. It's our first time to be involved in Hannover Messe, such huge honor, and we are truly grateful to Indonesia's Ministry of Industry for all the support and facilitation for us to be onboarding in this prestigious occasion. So in this talk, I'll discuss of how the potential of IoT can be unlocked and enriched by implementing on-device AI, especially with something called tiny machine learning. I'll share some why and how to implement on-device AI in IoT, show some demo, and how IoT and AI are being implemented in DycodeX solution. So before we start, allow me to introduce more about myself. Beside currently as CEO of DycodeX, I'm also Vice Chairman of Indonesia IoT Association, or ACOT. And for the last 13 years, I've been as a Microsoft Most Valuable Professional, or MPP, which currently for Microsoft Azure. So MPP is a title for people with deep technical expertise and unstoppable contribution to the community. And about DycodeX, we are a tech company with a big vision to solve big problems with technology. Today, we are solving real problems by adopting and combining the key technologies in Industry 4.0, which are Internet of Things and artificial intelligence, especially on device AI or embedded machine learning. In that area, we are one of the pioneers and unique player in Indonesia, but with global coverage, and continue to be the leader for the last 6 years. Since 6 years ago, we've been implementing IoT powered solutions, but we think we can do more. That for the last 3 years, we enrich our existing solutions by implementing AI, especially on device AI. As the title of this talk, we believe that by converging AI and IoT, hence AIoT, the potential of IoT will be unlocked even more. That will enable more use cases, deliver more values, and hopefully more opportunities. However, bringing IoT and AI powered solution to life is very challenging. Our mission is all about simplifying that by developing and delivering real world products and solutions across the technology horizontal and multiple industry verticals. Along the way, we also help other organizations, from startups to enterprises, to adopt IoT and AI into their products and business processes by providing custom hardware design, tailor-made platform, and also applications. All solutions are 100% designed, developed, and assembled by us in-house in Indonesia, from the hardware, firmware, all the way to the platform and application, end to end. Okay, so now let's jump into our topic of the talk. I want to start with a use case of machinery maintenance. We all may be familiar with the multiple approach to maintenance. The first approach is to schedule maintenance tasks based on a fixed, predetermined or fixed schedule, which ignores the actual condition of the equipment. This approach has the advantages of being simple to plan, but also has significant drawbacks in that maintenance may happen too late, resulting equipment damage or danger for workers, or it may be carried out when it's not really necessary. That's of course suboptimal, as the expensive assets may be replaced way before its RUL, remaining useful life, or the production chain needs to be held for several hours to days. Wall Street Journal reported that unnecessary downtime costs industrial manufacturers an estimated $50 billion each year. Another smarter approach is condition-based maintenance, which drives maintenance actions based on the estimated condition of the machine, typically monitored through the inspection or using data from embedded sensors. The benefit is that maintenance will happen before failure and only takes place when necessary. The drawback, however, the maintenance only begins after the machines begin to show the signs of failure, and necessary maintenance intervention may not be optimal for production scheduling. So that's why we need the third approach, which is predictive maintenance. The aim is to predict at the earliest point in time possible the maintenance action that will be required at some point in the future. It's based on condition monitoring combined with dynamic predictive model for failure modes. This has the advantages of optimizing maintenance for both machine's life and the factory's production efficiency. Now let's take a look the typical deterioration curve and related signals. For example, for electric motors, that begins with very early sign of failure via ultrasonic noise, then followed by vibration frequency and amplitude change that may be deductible to some specific problems. Then power consumption starts to rise, meaning the damage already happens. Further away, the audible noise is emitted, meaning the risk of failure escalates. It's finally give off as failure happens as the smoke is visible. That's the end of life, right? So predictive maintenance is all about enabling corrective maintenance to be performed at the earliest possible, since the first sign of failure emerge. So to implement condition-based monitoring and predictive maintenance on existing assets, we can retrofit that dumb asset by installing low-cost sensors and IoT device like the one that is provided by DycodeX. Now let's move forward and discuss deeper into a case to detect electric motor failure. So to build such system, we can leverage digital data from a vibration sensor. Then we can transfer the raw data to the cloud. Usually it takes about 1 kilobyte of data to get it right. Then analyze the data in the cloud to classify whether there's a fault or not. But this may be not always the best approach due to some limitation in its operationalization. For example, the device may be battery powered, and as we know, radio for connectivity is one of the biggest energy consumer. Another concern may be related to the performance and latency, as the prediction in the cloud may not be fast enough to allow proper remedial or preventive actions. Another approach is, instead of transferring raw data, what we can do is sampling and initial processing to the data. For example, by applying a fast Fourier transform, FFT, and only transferring that calculated data to the cloud. By that approach, hopefully we can still able to detect the fault, but we may miss a lot of interesting events that may be critical for that for the fault prediction or other purposes. So to overcome the drawback of previous approach, why don't we carry out the complete analysis right on the device, on the data collecting device itself, and may only deliver the conclusion to the cloud, right? So this definitely will save power and bandwidth and deliver conclusion quickly based on the complete analysis right on the device. Now, for that, there should be some kind of on-device processing, or in fact intelligence, built right on the data collecting device or microcontroller itself. So is it machine learning? Because when we're talking about machine learning, it's often associated with the cluster of high-power CPU and GPU system like this. However, for certain machine learning problems, such as classification, to determine whether what's happening right now, or for anomaly detection, to recognize whether it's normal behavior, and forecasting, for such problems, we can definitely exercise machine learning processing or inference right on the low power tiny microcontroller. And that brings us to the tiny ML, or tiny machine learning. So not only for predictive maintenance, but whole variety of other use cases can be enabled by tiny ML. Essentially anything that is based on messy high resolution data like accelerometers, sound or voice data can be enabled by tiny ML. We can, for example, implement keyword spotting or wake word detection, like the one we have in our smartphone or a smart speaker, like Hey Google or Alexa. Dia nyala. For fighting COVID-19, we can.
The answer to your calculation is 4.
For fighting COVID-19, we can build a tiny ML model that can differentiate whether a cough is COVID-19 related cough or not. And later I will discuss in more detail two of DycodeX products that leverage tiny ML for object detection and for example for mask detection, face mask detection, and also for activity prediction for animal. So to implement and deploy TinyML, there are certain requirements to meet. We need a microcontroller that is somehow machine learning capable at certain level. Nothing fancy really. ARM Cortex with DSP is enough. But having dedicated neural network accelerator like KPU, knowledge processing unit, or application specific IC is definitely more beneficial. During development, it's convenient to have ready-to-use development board. On software side, specialized compilers or converters are needed, usually to convert the model or to compress the model to be fit and optimized to run on microcontroller. And obviously, good documentation and free trained models definitely helpful to easily get started. This is typical or general workflow in TinyML. We can train our model in any framework that you are familiar with that usually output, depend on the framework, output Onyx, H5 or Cafe. Then we can do optimization to compress the model, to remove some operation or to replace in fact. And then we do conversion so that it will compatible with the file format recognized by the target microcontroller, and the output representation file for the model can be transferred to the microcontroller using SD card, or you can flash directly to the microcontroller. And then we integrate microcontroller optimized inference library so that we can do inference in microcontroller. Alright, so to easily imagine what we can do with IoT and TinyML, I prepare a simple demo. We don't have enough time to do live coding, maybe some other time. So the demo is about recognizing the state of a fan operation, whether it's currently off, normal operation, or possible fault. As you will see, the demo may seem simple, but it's directly implementable in the real world. For example, for exhaust fan that can be correlated with the cleanliness of the machinery. So this is the demo. On top, I saw a camera feed. This is the fan. On top of it, there's a microcontroller board with vibration sensor that is powered by ARM Cortex M4 microcontroller. This board is not connected to internet whatsoever. This cable is only USB cable to output the log message that's spit out by the firmware to the computer, so that we can see the log message at the bottom. As we can see, the fan is currently off. The TinyML inference that's now running directly on microcontroller is able to detect the fan is off. Let's turn on the fan. Now the AI is able to predict that the fan is now running normally. The blue LED is on. here. Now let's simulate fault condition. For example, by obstructing the fan blade, the AI will pick up the abnormal vibration pattern and predict there's an issue, red LED blinking, and removing the issue will bring the prediction to normal again. Let's simulate another fault by loosening the nut. The loose nut will cause abnormal vibration again, and the fault condition is recognized. Red LED is blinking. Now let's tighten the nut and see what happened. And we begin to see that the issue now disappeared. As we can see, the prediction happens in real time. Let's turn off the fan. Now all is off. So there you have it. Fan fault prediction powered by tiny machine learning running directly on IoT device. So as a key takeaways, predictive maintenance arguably is considered as one of the killer apps for Industry 4.0 with tangible return on investment. AI is an inseparable component of IoT, and now the new breed of machine learning is emerged. TinyML. It's not a hype anymore. It's a game changer. So next, I want to spend the rest of the live stream to discuss DycodeX products and solution that is powered by Internet of Things, and some leverage TinyML for on-device artificial intelligence. For example, in asset tracking, we have DycodeX that enables abundance of use cases such as fleet management, personal tracking, and recently for vaccine cold chain tracking for COVID-19 vaccine distribution. In agriculture, we deploy SmartRNAC in the spirit of improving farmers' life by providing platform and devices to assist farm management, especially in cattle farming. SmartRNAC is essentially a platform that features cattle wearable device and sensors in the farm. Also, the platform and application all to assist the farmers to increase the yield and reduce potential loss. So this is the cattle wearable device, an Apple Watch for cattle, if you will. It's packed with 15 sensors and actuators. The brain is ultra low power microcontroller with on-device artificial intelligence. It's connected to the internet over industry standard long-range low-power connectivity, either using LoRa or NB-IoT technology, all wrapped in IP67 enclosure. Again, this industrial design and electronics board are designed and assembled 100% in-house, all to ensure the seamless integration with the software all the way to the cloud. On-device or embedded AI will enable activity prediction like this feeding activity without the need to transmit raw sensor data to the cloud, as the AI inference runs right on the device. By that, we can present activity inside to the farmer. We think it will be very useful to reduce costs and potential loss. During this COVID-19 pandemic, we are contributing a solution for screening and tracing to help combat the virus spreading. We call it HitREX, which features embedded AI-powered contactless thermal screening, face recognition for attendance system and access control, and face mask detection by leveraging on-device AI, and also integration with QR code access control, and many more. HitREX differentiates against the competition by allowing flexible customization for both hardware and the platform, and deep integration with the third-party or existing system, all with affordable pricing. That's why HitREX has been trusted by more than 30 mid to large organizations for more than 100 deployments. from government, startups, state-owned and private corporation, to educational institution. Not only focusing on commercialization, DycodeX is highly committed and deeply involved in nurturing IoT ecosystem in Indonesia. We help government to regulate IoT playing field, especially during the field testing and the drafting of low-power wide area network technical specification regulation. I myself is quite influential in Indonesia's IoT ecosystem and has been working closely with government as I am currently entrusted as Vice Chairman of Indonesia IoT Association or ASIOT. Since the beginning, we also reach out to the community in the spirit of encouraging the young makers and more players into IoT field. To make it real, we have developing IoT prototyping platform from the hardware, because hardware is hard, to the software that enable easy onboarding into IoT, either for non-techie to professional maker. This Expectro 32 is an IoT development board like, popular Arduino Uno, but 200 times more powerful. Behind great company, there's a great team. DycodeX key person have 4 to 23 years of experience in hardware and software engineering, artificial intelligence, also project and product development. Our solutions and expertise have been recognized and awarded in national and international level. But more importantly, our solution has been entrusted and delivering values to more than 50 organizations around the globe. All of our achievements are impossible without the support and the collaboration with local and global partners for research and development, also go to market. So, if you are interested in bringing values to your products and business that enabled by combining IoT and AI, we are here for you. Drop us an email to hi@dycodex.com. Keep in touch. Alexa, switch off ring light.
Okay.
Thank you.